All right, so today we're going to talk more about three equations, three variables, and solving those systems. We talked about how to use substitution last time, so if you know what a variable is equal to, then you can just substitute whatever that is in for that particular variable in the other equations and create your equation 4 and equation 5. Remember, that was kind of our thing, was to create two new equations that have two variables in it, and then we're back to doing Algebra 1 stuff, which is just solving two equations, two unknowns. Right? So today we're going to talk more about, elimination and using the elimination method to solve three equations, three unknowns. We call these the substitution and elimination methods because that's what we're going to do in our first step to create our equation 4 and equation 5. But once we have our equation 4 and equation 5, then it's fair game. You can do elimination, substitution, whatever. So you may end up doing a mixture of both methods in the same problem. But I'll point that out to you here in just a few seconds. All right, steps for elimination. And you can fill in your notes here. And the steps are good to have as you're doing your homework. You need a quick reminder of what you're supposed to do. And so I'm not going to go through all these steps and read them to you. You can see them there. But go back and read through these. And as you're doing your homework, you get stuck. Try to go back and figure out which of these steps you haven't done yet. Okay? But basically the idea is this. We want to create our equation 4 and equation 5 again. Our two equations and two unknowns. Two equations, two variables. Before we do it by substitution, we can do this, number one, we can do this example by substitution also, if you wanted to. Maybe take this equation and add x, subtract 6y to get z by itself and get x minus 6y plus 21. And then go substitute that in for z here and z here. But as you're starting to hopefully realize, that's going to take a little bit of work. So instead, we can eliminate. Choose one of our variables to eliminate. Now you still want to create equation 4 and equation 5. So what you have to do is you have to pair these guys up. Take two different sets of equations, eliminate the same variable, and then you'll have your equation 4, equation 5, and you can go finish up with what you've been doing all this time. So in other words, here's what I would do. I'll look at the system here, and I try to figure out which variable across all three of them would be the easiest to get your opposites to eliminate, right? And as I look, I think the x's here would be the easiest to make opposites. Now, I'm not going to make them opposites right now for all three of them at the same time. I'm just trying to figure out, as I pair them off, and I'm going to pair them off now, which variable is going to be easiest to eliminate, because I have to eliminate the same one the entire time. So I'm going to take equation 1 and equation 3 first. And I'm going to eliminate x. And this works the same way it did for the two equations, two unknowns. I've got to make sure the x's are opposites, and they are. So I'm ready to go ahead and just add these guys. That's 0, this is 8y, this is 4z, and then we get 24. And here's my equation 4. Right? Two equations, two variables. I'm good. Now I'm going to set this aside for a second and go over and eliminate x again. But I got to choose two different equations to put together this time. And so I'm going to choose equation 2 and equation 3. The only reason I want to choose those guys is because the signs are already opposite. That's really the only reason. Now the tricky part here is you might look at this and decide to eliminate a different variable, or you might choose to pair up 1 and 2 and go eliminate x that way. So checking your work with someone else's work might be tough because they may not be doing this the same way. But you should still get to the same answer. Okay? So, to make my opposites, I got to multiply equation 3 by 2. I kind of put a line through the equation that I multiply something into, so I don't try to use it. Now I'm going to add the two equations I'm looking at here. So this is going to be 0. This is 11y minus 3z, and then 50, and this is your equation 5. Now we can take equation 4, equation 5, put them together, and solve for a variable just like you were doing with two equations, two variables before. Make your opposites for one of them. I'm going to do elimination again. You could do substitution if you wanted to, but none of the variables have a coefficient of 1, so it could be kind of tricky. So I'm going to multiply equation 5 by 4 and equation 4 by 3 to make those z's opposite, right? That common denominator between 4 and 3 would be 12, so I'm trying to make these guys 12. So we get 24y plus 12z equals 72. Then we get 44y minus 3z equals 200. Oh, sorry. See, this is, you're going to have to be really careful, pay a lot of attention to your details, because it's going to be very easy to make a very small, silly mistake. Like, for example, multiplying 4 times 3 in equation 5 here and getting 3 again, like I just did. So watch what you're doing and make sure that when you're adding, you add correctly too. That's going to be where most of the mistakes are going to happen. Okay? All right, so we're going to divide both sides by 68 here and get 4. Okay? So, just like before with substitution, now that we know y is 4, we just got to plug y. So we know one variable. We need to plug this into an equation that's got just 2 in it so we can solve for the other one. And equation 5 fits that. So we go 11 times 4 minus 3z equals 50. And now we're just solving. Subtract 44 from both sides. Make sure to bring that minus sign down as a negative on the 3. Divide by negative 3, and z is negative 2. Now that I know two variables, I'm going to substitute this in for an equation that's got 3 in it, so I can solve for x. And equation 3 works. So negative x plus 6 times 4 plus negative 2 equals 21. So we get negative x plus 24 minus 2 equals 21. Negative x plus 22 equals 21. Subtract 22, divide by negative 1, and so our solution becomes 1 comma 4 comma negative 2. That's our ordered triple. Okay? I mean, no way around it. 3 equations, 3 variables, always going to be a little bit of work. But I think elimination cuts down on some of the work. Just a lot of arithmetic, a lot of multiplying, a lot of adding. You're going to have to keep focused through the entire problem. Okay? That's it. We're going to pair up equations. We're going to do 2 sets of equations, eliminate, so we can create equation 4 and equation 5, eliminate the same variable, and then put 4 and 5 together, and I always eliminate again. So I'm going to always do elimination 3 times, unless something really weird happens, but that's it. Okay, number 2. We'll go a little bit faster here. I'll walk you through my process. So 1, 2, and 3, I'm looking and I'm thinking that the y's are going to be easiest to eliminate in my first 2 elimination steps, because equation 2 and equation 3 we already have opposites. As a matter of fact, I'm not even going to rewrite them. I'm going to go ahead and just add these guys together. Nah, this is going to make things too messy. So never mind. I am going to rewrite them. But I'm putting 2 and 3 together. Add these, you get 0. This is 8x. This is z and 8. Now I'm going to choose to put 1 and 2 together, again because those signs on the y's are opposites. But remember that you have to eliminate the same variable when you go through and do your elimination process for the second time. Might have been easier to eliminate z's, I don't know, but I've chosen my route and I've got to stick with it. So I got to multiply this guy by 2, this guy by 3, making those y's both 6. Oh. And there you go. Add these, you get 0. And so there your equation for equation 5. Bring 5 over to here. And then we're going to multiply equation 4 by 4 to eliminate those z's. So we get 32x plus 4z equals 32. So this is going to be 51x, that's 0, this is 51, divide both sides by 51, and x is 1. Now I've got to go find an equation that's got 2 variables in it, so I can substitute x in for it and find the other one. This one works. So we get 19 minus 4z equals 19, subtract 19 from both sides. And you get 0, divide by negative 4, and z is 0. So now I'm going to take 0 and 1, plug it in for z and x into any of the first 3 equations because those equations have all 3 variables in them. So we get 2 plus 3y equals 5, subtract 2, divide by 3, and y is 1, so our solution seems to be 1, 1, 0. Okay? And that's all there is to it. Okay? So for the rest of our examples, this becomes, like I said, kind of tough because you may choose a different variable to eliminate than I do. Both when you try to create your equation 4 and equation 5, and when you put 4 and 5 together, you may choose to eliminate a different variable again. So checking your work with mine becomes really, really tough. But what I'll do here is number 3 is designed for you to give it a shot. So go ahead and try it. I'll show you the answer. If you don't get the same answer, go back through your work and make sure that you pay attention to all those little details, making sure that you're adding correctly, that you're multiplying and keeping your signs the way that they should be, and all that kind of stuff. Okay, and this is what you should have gotten, 4, 3, 1. I'll say this. If you chose to eliminate y, then this work would help you. Try to decipher here. So multiplying equation 1 by 2 gets you this, and then putting, equation 1 by 2, yes, you get that. So you put, and then by putting 1 and 2 together, you can eliminate the y's. Here we've taken 2 and 3 and multiplied 3 by negative 1 to get this, which allows you to eliminate y again. Then you've got your equation 4 and equation 5 here. And you're going here, if you chose to eliminate x's, you would have gotten this. So if you did that route and you didn't get 4, 3, 1, then you can check your work. If you didn't, like I said, you're going to have to go back and just kind of go through and make sure that you added all your numbers correctly and kept your signs the same. You have to understand that if you did not get 4, 3, 1, that you obviously did something incorrectly. So you have to go back and look at it through the point of view of where is my mistake, not did I make one. Okay? It makes a difference. You'll find your mistakes a lot easier if you go into it knowing that you have to actually find one. There has to be one in there somewhere. Okay? All right, one more here for you to try. Go ahead and try this one, and I'll show you the answer, and hopefully you get it. If not, you can come in and see me, and we'll try to figure out what's going on. So go ahead and stop the video for a second. Try this one. I'll show you the answer. And there you go. So you got -2, -3, and 5. Okay, if you did not get -2, -3, -2, -3, 5, go back through your work. If you can't find where you made your mistake, feel free to come in and we'll take a look. Okay? I don't think there's a whole lot of benefit to looking at one more of these. But there's one more for you to practice. I will tell you that the solution should be 3, 0, -2. So again, give that a shot and see if you can get to that answer. If not, come in and see me and we'll figure it out. All right, that's it. Homework's out in Canvas. Have that done by next time.